Okay, we're going to be looking at exactly the same problem that we did in the first prototype 12 problem using equivalent resistance to solve for the current from the EMF source. So let's once again reproduce our circuit, and we see here an EMF on the left side of the circuit going applied to a resistor R, forming a junction with the middle branch that has resistor 2R, and then we have a left branch comprised of R and 2R. Once again, we want to solve for the current two ways. We've already used equivalent resistance. Now we want to use Kirchhoffs laws. So as our first step, we need to define a current in each branch of the circuit. The left branch, which is the portion from A to B, and includes the resistance R and EMF. The middle branch, which is the portion right between A and B, including 2R, and the left branch, which includes the resistors R and 2R. So I1 we will assign to the left branch, I2 to the right branch, and I3 is the middle branch. Now by branch, we mean a connection from one junction to another junction. So my second question is, how many unknowns are there? Well, there are three, I1, I2, and I3. So how many equations do we need in order to solve for three unknowns? We need three equations. So we got two laws to work with. We have Kirchhoffs junction law, which says that the total current going into any junction must be zero. And then his loop law, which says that the sum of the potential differences around a loop, a closed loop or closed circuit, must be zero. So let's start with junction A. What does Kirchhoffs law tell us about the currents entering and leaving junction A? Simply says that I1 minus I2 minus I3 must equal zero. And we will call this equation 1. Now, I am going to choose an arbitrary direction. For the path, I'm going to take around a closed circuit. And the closed circuit that I'm going to choose is the circuit on the left-hand side, going through the left branch and back through the middle branch. So now let's apply Kirchhoffs loop law, sum of the potential differences equal to zero. Well, we're traversing the EMF in the direction of energy gain, so that's a plus EMF, or plus E. We traverse the resistor in the direction of current flow, so that's a minus I1R. Coming around back through junction A through 2R, we traverse the circuit in the same direction as I3, so that's a minus I3R. So the total number of potential differences is the EMF, I1 minus I1R, and I3 2R. So write down the equation for that loop law. And of course it is EMF minus I1R minus I3, and that should be 2R. And I now show it corrected. Now choose a closed path for the right loop. We just did the left loop. Let's now do the right loop. And I'm now going to choose to go around that closed path in the clockwise direction. So once again, we want to apply Kirchhoffs loop law and sum up the potential differences. So let's do that. Well, we're going through 2R in the direction opposite the current flow, which means it's a plus I3 2R. Then we're going in the direction of the current through R, so that's a minus I2R. And we're going in the direction of the current through 2R on the right-hand side, and that will be a minus I2 2R. So let's write down Kirchhoffs equation. And we have 2I3R minus I2R minus 2I2R equals 0, and that is equation 3. So we now have 1, 2, 3 equations. Now solve the 3 equations and the 3 unknowns. Okay, first thing I want to do is I want to substitute for I3, I1 minus I2. And when I do that, I find out that we end up with the EMF minus 3I1R plus I2R equal 0. And you may have noticed that I corrected that. And if we work with equation 3, we have 2 times I1 minus I2R minus 3I2R, and that can be reduced to 2I1R minus 4I2R. Now we have 2 equations and 2 unknowns to solve for, the equation 2 and 3. Now solve, and you should come up with 5 times EMF over 11R equal I1, the current from the coming from the EMF source. I'll leave it to you to fill in the details. End of problem.